I've been putting be kind messages at the top and tail of PowerPoint presentations since speaking in Caribbean DevConf, which was as awesome as it sounds. A couple of years ago, I was thinking, what's a good slide to have to just make people think a bit before I start? And apart from saying you can go somewhere else, emphasizing kindness, whether that's in communications, emails, team meetings, code reviews, etc. There is always room to be kinder. This is not in any way implying that any of you are not kind people. It just never hurts to be reminded. Speaking of which, sort of looking out at you, I see it's a room full of white men again, nearly. I think there is a general improvement, gradually, at least in the conference in general, not so much this morning. So apparently, I as a speaker only attract white men, nearly, which is really unfortunate, because I'm very, very passionate about diversity, which is why I sort of run to audiences for almost every talk I give. This is incredibly important. I will mention a bit. It does actually tie in with drumming just a little bit. And if I forget to say something about that, then ask me a question later on saying, hey, you said that you talk about diversity. It's something that we can all do something about by just looking for opportunities to increase access to our wonderful industry. Okay, so exploring a drum kit, or in particular, exploring this. This is my drum kit as far as we're concerned today. I do have more of it at home, and I will hopefully remember to show a video later on of some silliness involving the actual kit itself. What we're going to do today, the point I'm hoping of you being here is that you can have fun with me. I'll be having fun, certainly, even if you're not, thinking about what I've been doing since about last July in terms of coding for my drum kit. We will reflect a bit on how I've managed to turn this sort of learning to play drums. I could just have bought an acoustic kit and learnt to play drums, and I would have enjoyed that. I could have bought an electronic drum kit and just learnt to play drums and enjoyed that. I could have just written some code and enjoyed doing that as well, but I've enjoyed writing the code and starting to write some blog posts and now giving talks. And this is probably a good point to mention privilege, that I feel immensely privileged to have the space, have a house and enough space to have a drum kit in it. It's actually in my shed, which is my home office as well. Then have enough time to work on this for fun as well as learning to play drums, and then having the opportunity to blog and then give talks about this. It feels like this talk is almost the definition of privilege. However, it does help professionally, and what I'm encouraging everyone to do is think about how, if you've got a hobby that you're quite happy to add coding to it, and that it works out in that particular way, how you might be able to just sort of extract a bit more value and improve professional skills at the same time. We'll think about things beyond, I've written code, I've also read a bunch of documentation, learned a bunch about installers and things. We will look at some of the actual code itself, and hopefully you'll go away thinking, hey, yeah, I can do whatever it is, whether you're watering the garden like Troy Hunt with a sort of irrigation system that maybe you can do better than the onboard system for predicting when you need to do it, whatever it is. So, this is a stock photo of the drum kit that I have. This is a Roland TD17 KVX. I started with a KV, but wanted to expand a bit. And it's an electronic drum kit, as you can tell. So the things, let me see if I've got a laser pointer, because pointing normally is not going to work. I have, and it works. Right, so we have a snare drum, high tom, mid tom, floor tom, a ride cymbal, crash cymbals, hi-hat, and a kick pedal. How many of you have actually done any drumming before? Okay, that's good. So those terms will definitely have made sense to all of you. One of the learning experiences was coming into a brand new world. I'd never touched a drum kit before, other than maybe picking it up at school just to go and then done. So I had no idea. I knew what a snare drum was, but I probably couldn't have told you that these were toms. I had no real idea of what a kick pedal would be for, in terms of the music. I certainly didn't know that hi-hats were sort of almost the backbone of drumming. I'd expected that to be a rare thing and that you'd normally play it open and occasionally close it. Quite the opposite. And definitely no idea about crash cymbals and ride cymbals. Anyway, I bought this set in July last year. I went with a good friend of mine, Alice, to go and pick. So she got me into drumming. We were at church. She was drumming in our band, and I said, that looks fun. Maybe I should get a kit. And she's saying, yes, you absolutely should. I will come and help you pick. I will do all kinds of things to get you started. She was very enthusiastic. So lesson 1, be enthusiastic about what you love, and you can spread that enthusiasm to other people. So she came with me to the local music centre, and we were looking at the Roland TD1, which is a more beginner's set and significantly cheaper. And it looks a bit more beginnery, and I'm a beginner. It would kind of make sense. But I looked at the module on that. I didn't point out this is the module, which is the thing I've got over there, also known as the brain of the drum kit. That's what takes the signals from the various pads and turns them into noise, basically, and MIDI signals. And that's what we'll be programming against. And I looked at the module for the TD1, and I thought, that looks quite primitive. And I didn't have any specs or whatever. I wasn't looking up documentation at the time, but I thought, that looks quite primitive. I'm unlikely to be able to do much with that. And I looked at this and thought, that looks like it's probably got rather more. And I knew a bit about the specs, so the terminology gets really quite confusing. But while this is a drum kit, this module has 100 kits on it. So you can basically say, right, now I am playing an acoustic kit. Now I am playing a kit that sounds like I'm in an arena stage, for example. And this has 100 kits. The TD1, I think, only has 12, and you can only choose between a much smaller number of instruments. And I thought, it's much more likely that I'll be able to do something interesting. I didn't really know very much about what at the time, but I'd be able to do more interesting things with the TD17. So that's why I got it. And it turns out I was right, because the thing that you can do on here, so I haven't got sort of fancy cameras set up and whatever. This is currently set to acoustic, all wood. And I can assign different things. So currently the kick pedal is for a beach kick drum. And I can say, no, I don't want that. I want an 18-inch maple kick drum instead. And I do that with, the UI here has like 5 lines of LCD and a bunch of buttons, turny knob, and a few extra buttons around the side. Now, this is a really well-designed UI, given the constraints that it's got. But I thought, we have mice and keyboards and monitors. We can do better. In particular, when you've got so much that you can do on here, I'll show you in a minute just how much you can configure. I really don't want to be doing all of that on here. I want to be doing it on a computer. Bear in mind, I haven't yet played the drums, okay? And we'll come back. I have spent more time coding than playing the drums. That is gradually writing itself. So I will show you now what I've been working on. So this is currently a WPF app. It's not actually running on .NET Core 3, simply because we use... there's one thing that I couldn't do with .NET Core at the moment, which is playing sound directly. So let me show you this. So this screen is, I've recorded all the sounds from the module by basically sending MIDI signals saying, okay, start playing this note, stop playing the note, start playing the next note, or rather, sorry, start playing the note, then change to be a different instrument, play the note. Change to be a different instrument, play the note, and recording samples for all of those. The point being that, as happens to us all so often, we want to be able to reconfigure our drums but we don't have the module with us and we don't have the drum monitor with us. I'm sure it's happened to you several times today already. And if you don't know what some of the instruments sound like, then it might be difficult. So, you know, I've got headphones. This should be working. Could we check the sound coming from my laptop, please? There we go. Right, so that's a mahogany snare, maple snare, steel snare. So you kind of know what all those things are going to be. But when you go to the percussion, and having made fun of myself for this being an unusual thing, I did actually, the reason for doing this was due to having problems once trying to put together a Latin-style percussion kit and not knowing what on earth some of these instruments were. So, you know, we all know cowbells, that's fine, can always do with more cowbell. But I had no idea what, for example, a cuica drum is. And this is now my favorite instrument. Isn't that just joyful? And that's actually a drum that, I think it's Latin American. Sort of from the top, it looks like a normal drum with a bit coming out of the top, but it's actually got a stick on the back, and you sort of rub the stick. Frankly, it looks a little disturbing to watch people playing it. Look at the YouTube videos, you'll see what I mean. So I had no idea what these sounded like. So I thought it would be a really good idea if I could record the sounds that came off the module and do that. Unfortunately, this uses something called N-Audio, which it mostly works for .NET Core, but you can't list the output and input devices. Like, if you know I want output device 1, then I think it would all work fine. But in order to list them and get the device capabilities, it needs to be on the .NET framework. So I'm sure there is a feature request already for N-Audio. I'm sure it will be sorted at some point. And other than that, it definitely works on .NET Core. So this is the sort of home screen. I will load a file that's just a fairly standard. This is, I think, factory settings. And the whole system is effectively a tree of containers and data. So we have the triggers. Trigger is the more technical term for the instrument that you've got that you hit. That has triggers within it. So you've got the pad contains the trigger, and the triggers that I've got attached to mine are a KD10 kick pad, PDX12 snare drum, etc. But most of the detail is in the kits. And you can see there are 100 kits, so 50 presets and 50 user ones. I don't have the reach kit on here. I'll show that later. So within a single kit, you say, well, okay, normally the kick head is a beach kick, and it's got some muffling applied, and it's got a certain amount of snare buzz, and then there's a sub-instrument. So each instrument, you can layer two things, one on top of the other, and kick doesn't have a rim, but when you've got the snare drum, and most of these have a separate head and rim, and all of these have different tuning levels, and you get different kinds of tuning. So where before we had snare buzz, which is kind of bizarre for a kick, but there we go. We have strainer adjust on the snare head. So it's all kinds of, you can see how much data there is in all of this. And then the other things within a kick, as well as the instruments, you have the MIDI configuration. So you can tell this module can play MIDI out as if it were a keyboard, for example. And there are different notes assigned. So one of these is probably middle C, for example. And these are just conventional, how do you map a drum to musical notes, so that you would generally tell some MIDI player, hey, I'm playing a drum kit, and it would say, okay, that means middle C is a snare drum, whatever it is. But you can reconfigure that. And importantly, there's this kit multi-effects. So there are lots of different bizarre effects you can do. This has a delay which is actually switched off, but if I go into edit mode, and there's just a chance that it'll crash at any time, of course, but you can see there are many, many different kinds of things. I've no idea what a flanger is even. Overdrive to distortion and T-wah, all kinds of stuff. And each of these has a different set of parameters. And this is all going to be important later on. There may be a test. So we'll cancel the changes to that. But I wanted you to have a general idea of what I've been building. That's one. The GUI is the main thing I've been building. Just this week, I've also been building a console application for this. Is that fairly visible near the back? Yep, okay. So if I go into, and I should point out, all of this is available online at github.com/jskeet is me, and then demo code contains everything I do for stuff like this. So the drums is within demo code. So if I go into vdrumexplorer.console, I thought, I have heard from Kathleen that there's this great thing called system.command-line. That sounds like a fun thing to play with. So I've been starting to build a small command line app, which currently, come on, sorry, it's just rebuilding. Right, so I can currently list the devices available, import a kit, which means I couldn't work out whether import should mean copying from the module to the computer or from the computer to the module. And then I can show the details of a kit. So if I list the devices, this is currently using, I used to use something called Sanford MIDI, and it's now using Commons MIDI, I think it's called, for portability purposes. So you can see that the computer knows about the TD17 as ID 0 for input, but for output it knows it as ID 1. And then it's tried to find anything where the input device matches the output device, and then it's sent a MIDI signal saying, please tell me about yourself, and then waits for a response, and then says, I know what that means. That's a TD17 drum kit. I can import a kit. See what the command line arguments are for that. Right, so I've got to specify the kit number. I'm going to put 60, which I happen to know is one that I've done specifically with tambourines and claps for S Club 7's Reach. And I'll just put it to reach.vkit. And this is now using the same file format that the module, that the vDrum Explorer GUI uses. So I could now load that in the GUI, or I could just show it. I think it's showkit. And this now dumps all of the data in JSON. And, well, let's pipe it through less, just so that we can see. There's quite a lot of it. So that's why I thought a GUI would be useful to start with. OK, that's given you a basic demo. So I want you to sort of bear that in mind when I then talk about more interesting technical things. So how does all of this work? The first thing that's important is there's documentation, and really quite surprising amount of documentation. We've got some screenshots later on that are actually meant to be demonstrating specific points, but they are just screenshots straight from the PDF that I downloaded from the Roland website. I think the TD17 is about 60 pages with all the details of the data that's on there, and the TD50, which is the sort of big brother kit, and there's now a TD27 that came out about 3 days ago that I now really want, but it's like $2,500, so maybe not. The documentation it's reference documentation very much. It kind of assumes that you know what you're doing with MIDI to start with. It's not, here's how you would build a program to to modify the configuration. And surprisingly enough, I did look to see whether anyone else had built something like the VDrum Explorer. I couldn't find anything, which is a little odd. I think real proper drummers, which I'm never going to be, don't end up using the sound effects from the module. They put it through something like Superior Drummer or some workstation and get even better sounds. These are nice sounds, but they're not sort of probably concert-level sounds. So the documentation tells you, here are the MIDI commands that I support. And here are the normal MIDI commands, like note on, note off, etc. And those go in each direction. So I can tell the module to play a note, and it would take too long right now, but if I'm demoing later on, I may get it to do that, so that if you're configuring your kit and you say, OK, well, I think I've got it how I want, but let's find out, from VDrum Explorer, you can say, please play it now. And normally that would be connected to my drum kit monitor, where monitor isn't like something that you see, it's something big, a speaker, basically. Slightly confusingly, I have another monitor, as in a visual monitor, just for my drum kit, so that when I'm playing on a tutorial game thing I've got, I can see easily rather than having to go over to the laptop. So I've got several different monitors involved, meaning different things. Anyway, the documentation starts with, here are a couple of things about normal MIDI stuff, and then here are some system-exclusive messages. And the idea is that the MIDI protocol has a bunch of standard things that every MIDI device is going to support in the same way, and then there's manufacturer-specific system-exclusive ones, although there's one system-exclusive command that is actually standardized. It sort of uses the way of doing system-exclusive messages, but it's for saying, please identify yourself, the thing that I used before to say, hey, what devices are there? And the way that the TD-17 and the TD-50 work is, imagine that the module has a big block of memory in it, just a huge block of memory, and that's got all the configuration in. And MIDI is unfortunately MIDI 1, and I think MIDI 2 is just being ratified or has just been ratified, but for MIDI 1, it's unidirectional. So you have to send something. You open two different channels, one for writing and one for reading. You send a request, and then you might get a response. You hope that you will get a response. There is nothing saying there was an error, or I'm done giving you a response now. You just kind of sit and wait and hope. And this was quite weird to model, although it did mean that C#'s asynchronous aspects fit really well with this. You send something, and then you can say, well, wait for up to 3 seconds, but as soon as you see what you expect to get back, you can finish, and it all works quite nicely, but took a little while to get my head round. You could send several requests and get back several responses. And that's how you find out what is in the memory. If you want to write something, so the first write that I did was to say, I want to change the name of the kit from acoustic wood to test, and it almost certainly was test or John or something unimaginative. You send the same, the thing that you get back as a response normally, the data set, you use as a request. So it's a little bit odd. You've got this command that is either I'm responding to a what's your data, or is here's some data that you should copy into your copy of the memory. So that's slightly odd to start with, and then comes 7-bit addressing. MIDI is a 7-bit protocol, so the top bit is used for signaling purposes, and the documentation for the module always talks in terms of 7-bit addresses, so the top bit of any address isn't set. And this makes it very, very odd to do maths, because effectively 127 plus 1 is 256. I mean, it's all written in hex, and I haven't sorted this out as well as I want. I've got some code in various places saying, oh, if it looks like you've added something and gone into an area, if you've added 1 to 128, and now the top bit is set, then just add another 128. And it feels wrong. So this is the first lesson that I've been pondering is how do you address that impedance mismatch between we want to do maths on a continuous set of integers, but there's this idea that this bank has half of it gone because the top bit can only ever be 0. So currently, all of my schema, I'll talk much more about the schema in a minute, the schema is written with the addresses represented as these 7-bit things. So you'll never see in the schema something with the top bit set. And currently, the code propagates that all the time. Now, I've been thinking recently that I should refactor everything to say, yes, when I'm writing the schema, I'm copying the schema out of the documentation. I want to be able to copy exactly what it says. But internally, I probably want to sort of remove all of those bits that are always going to be 0 so that I can do regular arithmetic on it and then expand it again for display purposes if I ever need to. It does get a bit weirder still, though, because in some places in the schema, I want to be able to refer to something else. I'll come back to that later on. But that makes arithmetic really weird. You sort of want to be half 7-bit and half not. So let's talk a bit more about the schema. This is a screenshot from the documentation. The exact details don't matter too much, so don't worry if you can't read it near the back. But this is the top level, and this is saying at address 0, we have current, which basically is which kit is currently selected. And then it's quite loose with the memory here, so we're going straight to 0, 1, and then 6 zeros for the setup. And then there's a block that's the trigger, and then there's 100 blocks, each of which is, if I say 2000, as in hex and bearing in mind the 7-bitness, each kit takes up that chunk of memory, and there are 100 of them. The fact that 100 is quite a big number is fairly important in a bit. And then each of those kits, so the word on the right here is sort of what the container type is going to be. So container is just my word for it, but if you imagine this is a tree and this is starting with the current container, setup container, trigger container, and then 100 kit containers. And then later in the documentation it says, well, a kit container is one of these. And instead of start address, we've now got an offset address. So this is within that chunk of memory for a kit, and there are 100 of these, we have all of these. And this has some stuff at the top that is just general. We saw like the kit MIDI is the MIDI mapping to different notes. And then we've got 5 blocks, each of which has a repeated thing 20 times. So kit unit common, I think, is general volume and things. That's not instrument specific. But then kit unit main and kit unit sub, each of which has a kit unit inst for instrument. And then we've got the vedit parts as well. So this is vedit when it comes to an instrument is things like the muffler and whatever. So we have a lot of repetition here, but importantly for our application, we don't have, it's not 20 times here's an instrument and all the relevant information is just in one block. It's here's all one part 20 times, here's another part 20 times, another part 20 times. My first pass at a GUI presented it like this. That was horrible. And for a while I had different view modes, so you could have physical mode versus logical mode. And then I removed it because no one would ever want the physical mode unless they were debugging, and I could just handle it. So hopefully you're getting some of the idea of what the data looks like, but then there comes overlays. Now, do you remember I showed you, there are basically 2 kinds of overlays we've got. One is for instrument editing, and one is for kit editing. So do you remember I showed you there was delay, and there was overdrive and TWAR and all kinds of things, and they all have different parameters. And then different kinds of instrument, like a snare drum has snare buzz and muffling. You don't muffle a cymbal. Instead, one of the parameters is the cymbal size. So as it gets bigger, it gets deeper. And this is where my GUI needs to display the right kind of thing. So let me show you what that looks like in terms of documentation. So the kit unit vedit, which was one of the top-level kit things, just says it's got some parameters. And each parameter is 32 bits. Well, actually 28 bits, because the top bit of each of those bytes can't be set. And in fact, it's not even that. It's 16 bits. You can only get 16 bits of information in each of the parameters. But what the parameter is depends on something else. Here's the instrument version. So this is for a kick. So if your currently selected instrument for a particular trigger is a kick, any kind of kick, then you get tuning, muffling, and snare buzz. The snare name is a little odd there, but there we go. So I needed to represent all of this information. For one thing, there was a lot of typing involved. No, I didn't do OCR and try to magically generate all of this. I typed a load of JSON in. I'll show you in a minute. Finally, a little bit like overlays, but not quite the same, are conditional fields. So when you have a delay or something like that, you can set the timing, and you can either set it to a particular number of milliseconds, or you can set it in terms of a musical note, so that if the device knows the tempo, it can say, OK, well, you've got a quaver or an eighth beat. I don't know why drummers don't seem to like referring to crotchets and quavers and semiquavers. They refer to quarter notes and eighth notes and 16th notes. Don't know why. But you can synchronize it either on a millisecond basis or a musical note basis. And the musical notes on the little LCD, they've only got about 4 by 6 pixels to play with, but they managed to get sort of hemi-demi semiquavers in there quite amusingly, and then triplets of those. But in the GUI, I need to be able to remove or add the fields based on what's going to be there. So I guess what I'm asking you to do is think, how would you represent all of that in a schema? It kind of gets a little bit weird. So I started just by writing a bunch of code. I didn't have any data. I thought, OK, I will, public class kit, public kit MIDI, get set, etc. So I could just write some code. And I thought, this is going to get really, really tedious. I'll come back to the object model, actually, later on. But if I'm not writing code, what JSON do I write? I had this goal that ideally I should be able to run the same code against a TD-17 and a TD-50. The TD-50 is pretty much professional. You do get people playing concerts. When I went to see School of Rock, I'm pretty sure that one of the drum kits they were using was a TD-50, and it has quite different information. So I thought, if I make everything just data-based, schema-based, with a JSON file, I can get away with no custom code. And so far, that is the case. I have never used the TD-50 other than in a shop. However, I do have a couple of brave alpha testers who have run this code themselves, and they say it basically works. So in the schema, how do I do all of this? How do I represent these overlays? How do I represent conditions? And is there some industry standard way of doing this already? Maybe it's just possible that there is already some framework out there that I could say, read the documentation, and it says, here's how you represent the schema, and I would still need to transcribe the schema, but then it would generate the GUI for me automatically, and all be great. I didn't find that. I didn't look terribly hard. Any reasons why I might not have looked terribly hard? Is anybody there? Yeah. It wouldn't have the fun, exactly. This is a project that's meant to be fun, and I enjoy writing the code, and I enjoy making these kind of decisions. Let's show you a little bit about what the schema looks like. Let's stop this. So if we look in the TD-17 folder here, we can see the root. This should be fairly familiar. So we've got current, and that's a current container setup, and then when we come to the kit, we say, OK, I know how to format the kit number, and I'm going to repeat however many kits I've got, and I will have it. So it starts at 3 6 zeros, and then there are however many kits I've got, and they're 2 0 0 0 0 apart. And in fact, the TD17 sort of metadata says there are 100 kits on this instrument. I didn't want to embed the number 100 loads of times. Despite the fact it's never going to change. It's not like the TD17 is suddenly going to gain more kits. It just felt like something that was useful to be able to represent as a variable, which is another concept that having it in the schema feels a little weird, and obviously there's a load of custom code to represent all of this. Even things like this resource instrument groups.json, and we'll see later where the containers are. All of these containers, this $resource, that's not standard at all. I've written some code to say, parse all the JSON, and I didn't write the JSON parser, it's using JSON.NET. Parse all the JSON, then look for every value that's a string, every J token. If it's a string and it starts with $resource : then load that JSON file and substitute it for the J token. It was a basic way of doing includes, as it were. Out of interest, does anyone know, is there a standard way? I know there is in XML, you can include other files. Is there a standard way of doing this in JSON? No? OK. So I guess I've not reinvented the wheel there. So as well as so I needed to represent the schema, and that was a case of copying it pretty much from the documentation. But then I had to come up with how are we going to display this, and going from a physical view to this logical view took a long time to get right in terms of the design, or when I say right, I mean to the state that we're in. So I knew that it's a tree view, so each node in here has some details, which are the stuff that's on the right-hand side, as well as children, so this is child nodes that would be on the left. And then this needs to do repeats, and then there's this idea of a path into the data. None of this is particularly innovative, but I had to come up with it all and work out exactly what I was going to do. Let's look a little bit at the code representation of this. So I'll come back to what I deserialize as the JSON directly. But in the end, I wanted to come up with something that was immutable as the schema. It's because the schema for the TD17 is not going to change. However much I change the data, the schema itself is not going to change. Immutable data structures for the win. Great. It's kind of tricky. So I wanted to have the idea of a container, and I also wanted to have the idea of fields. So I have an iField interface. I've got an iContainer interface. The details here aren't going to matter, but I want you to think about two questions. Does it make sense for a schema to know the fields that are within it and the containers? Does that seem like a good thing? It's not much of a schema if it doesn't know. If I can't navigate down from a schema to the fields, what on earth am I going to do with it? OK. Does a field need to know which schema it's in? Hands up those of you who would try to model it so that you could ask a field what is its parent, for example, which would be another container or maybe the schema itself. OK, not many. It's interesting. Out of interest, how many of you think that a field shouldn't know, or shouldn't at least care which schema it's in? OK, right. So most of you are still awake. This is good. Do you remember the condition that I had earlier on? If you have a field, you've got one field over here saying, I am the choice of instrument. And I've got another overlay field that says, right, this field is actually a container, but which container it is will depend on another field. If I can't navigate up the tree in some way or other, how do I represent find that field over there? Or how do I know if I want to work out the minimum and maximum value of something, and that depends on the schema. For example, the schema contains all the possible instruments. But an instrument field kind of needs to know what schema it's part of to know how to format things. You know, it's got some bytes from the module, from the data itself. How do I represent that as a string saying beach K? It doesn't say beach K in the data, it says 1, I think. So it's got to find that which is in the schema. So it turns out it's really useful for a field to be able to get to its schema. Can anyone see the problem? Which do you construct first, the schema or the field? Bearing in mind that once you've constructed it, you can't change either of them. This is not a new problem. Any F-sharp programmers are probably thinking let rec right now. And that's about the limit of my F-sharp knowledge, so I hope you're impressed. And it turns out what I've had to do, and I still feel this is ugly and there should be a better way, is when I create, let's see, I think it's in module schema. The module schema constructor, which is quite large, let me show a little bit more. So it validates some JSON, loads some instruments, and then here we go. This is the important bit. Don't worry too much about fixed containers and things yet, but build the root container, passing in this. How many of you are scared by that? Yeah, this is within a constructor. You're letting this escape from the constructor. Like, yeah. Note the now do everything with fields, because we've got to do some other stuff. We populate everything other than the fields first so that field construction can rely on it. So we're telling our fields about the module schema, and they're going to rely on most of the module schema being populated. This is an immutable type. I shouldn't need to care because it can't change. It's either going to be populated or it's not, except during construction. Hopefully you can see how this is immediately, I don't care about drums, this kind of problem comes up in real-world code. How many of you use immutable types in your C# code? Right. Have you run against this kind of problem where you've got two types that want to refer to each other? Yeah, it is painful. I wouldn't say I've now got a great scheme for it, but it's, yeah, I've got a slightly better handle on the problem itself. Right, while I remember what else I was going to talk about, I said I was going to talk about diversity and drumming. And this doesn't relate to anything technical, so it doesn't matter when I say it. Since I have started learning drumming, I hear music differently. So I tend to mostly listen to Broadway shows, so the t-shirt that I came in, because I didn't want to come into London wearing my C# in-depth t-shirt, there's a discount code on the back. If you want it, let me know, and we'll talk later. In fact, if you want it, you could take a photo now. No, come and talk to me afterwards. But I was wearing a Hadestown t-shirt. Hadestown was in the National about this time last year. Sadly, it's now only on in New York. If you're in New York, please go and get a ticket and just adore it because it's wonderful. But it's got a particularly strong drum part. I wouldn't have heard that nearly as much this time last year before I'd started learning to drum. Everything I listen to is now I'm seeing in a different light. If I had a team of people analyzing a particular musical and saying what was particularly strong or not, if they were all, say, trumpet players, do you think they would see the problem in the right way? Or would they particularly focus on what's good and bad about the trumpet and maybe be overcritical of the trumpet part and not really care whether there are mistakes or whether there are brilliant bits in the drum part? I think so. We each bring different, we have variety and diversity in our life experiences anyway, but I'm guessing that if you line up 10 white men in their 40s and look at their life experiences, that won't be as diverse as a racially and sexuality and gender diverse team. So if you're thinking about real world problems, you want to bring real life experiences, and bringing a diverse set of real-life experiences will just make you a better team. Okay. I vow I will get diversity into every talk I do, but in this case, there was no forcing. I've been really surprised by how much I hear things differently now. Okay. So, let's talk, I'll leave this up just while I talk about them, as I don't have anything to show for most of these. I will come back to Gui Inheritance, because that I do have code. So, I started off with WinForms. And again, with .NET Core 3, with a preview. I was going to write a whole blog post about how do you turn on high DPI in Windows Forms in .NET Core, because it took me probably an hour to get that working. And then I found that when they released .NET Core 3, it comes out of the box and it's all dead easy. I started with Windows Forms because I was more familiar with it. The designer didn't work in the preview of Visual Studio I was using. But that's fine, because I prefer writing GUI code for WinForms, sort of programmatically, building the controls myself, because that's what the designer's doing behind the scenes, and I can write cleaner code and know what I'm doing a bit more. When I moved to WPF, that was an entirely different matter, because I love XAML. And I should say at this point, I know only slightly more WinForms and WPF than I know about drumming. There have been a couple of GUIs that I've put online for whatever reason, so you can see just how bad my GUI design skills are. But it was a really, really pleasant port from WinForms to WPF. It took me 3/4 of an hour. Now, the GUI wasn't quite as advanced as what you've seen now, but it was mostly there, and it was pretty much one-to-one. That's partly because I'm doing WPF very, very badly at the moment. So I build all the sort of root of everything in XAML. Let me show you some of the XAML. So I'll show you the Data Explorer XAML. We've got a load of stuff at the top, and then some command bindings, and then there's some stack panels for the menus at the top, effectively. Not really menus, but... and then the bulk of it is a grid that's got a tree view, and then whatever's on the right-hand side. And all of the tree view itself is built up programmatically, and so are the group boxes that are shown on the right-hand side. They're all in code. So none of this is nice code, but there's a load of group boxes that I create and do all of this. All of this probably should be in XAML somehow, but I don't know enough about WPF to do it yet. So one of the things that I'm not doing properly is I'm not using view models at the moment. The form, window, whatever you call it, knows about module data and asks the module data, please format these fields as text, and then creates text blocks, etc. What I'm thinking, having started with some code for the schema, and thought, no, that's far too hard, and then I've got some JSON, my next step is going to be to have some code for the schema. There are a few reasons for that. Firstly, it should make it much simpler to refer to overlays, because I can just say, hey, this field depends on this field, and have a reference to the field instead of knowing, well, it's at this offset, so please navigate up a bit and then down a bit and things. It should also, I hope, make all the change notification just work out of the box. And it can also, hopefully, separate me from my current idea, and I haven't implemented any of this, is that the view model will, I don't know how much separation there'll be between view model and model, or whether the model itself is the module data, and the view model says, I know how to reconstruct myself. You give me this huge blob of bytes, and I will construct an object model that's got kits with strings and numbers in, rather than just references to fields. My plan is that I will start writing that code by hand. I could start by saying, I will generate it directly from the schema, but code generation is hard enough when you know what you're doing. And I don't yet know what the output needs to look like. I will need to fiddle quite a bit. So one of the things I have learned from my past few years of building the .NET client libraries for Google Cloud Platform is that you don't automate what you don't know how to do manually. Okay, so the skills transfer flows both ways, and that's one potential lesson to actually take away from today. Don't automate what you don't know how to do manually. Do it manually a few times, ideally in slightly different situations, so that you don't assume, yes, I will always be generating this particular API, so I'll hard code that API name into the generator. No, some things are going to vary. See if you can get a handle on what's going to vary by doing it manually, where it's really easy to change. Then you can write the code generator. I mentioned Gui Inheritance. Let me run this again, because I only demonstrated half of the GUI. The other half is very similar. So you can load the whole drum kit. So this has a root and kits under it. Or you can load a single. Let's load the reach kit that I mentioned before. So that has, where am I? Yep, so we've got claps for the high tom. Can you see how similar these two UIs look? They've both got exactly the same code for handling the details over here and the tree view over here. They have a few different things. Sorry, I've got the wrong. It's these two. Okay. There are some differences. So when you're looking at a single kit, it makes sense to have a button to say, I want to copy just that kit onto the device, onto the module itself. That doesn't make so much sense for a whole kit. You can copy any particular, if I have the copy data to device button here, that will copy anything that's under this tree view node onto the device, but there's nothing kit specific. So when you've got two UIs that similar, with a little bit of different code when you want to save a file, save the representation of what's here, well, what file extension are you going to default to? How is it going to do that saving? There are a few differences. How many of you write GUIs? I know these days writing actual client GUIs is this something that comes up every so often? This GUI is very, very similar to that, but there are a few differences. I honestly didn't know how to handle this to start with. So what I did was I used my favorite method of code reuse. Anyone know what my favorite method of code reuse is? Copy-paste, yes. Because, and this, I hadn't thought about it before, but it's the same lesson as don't automate until you know how to do something manually. Until you know how similar two things are, you can't really say whether they should be one type with occasional specialization or whether they're two types that maybe use some helper classes along the way. So I started with completely separate code, but deliberately a copy so that I could diff them. And then I made it do the right thing for each GUI, and then said, OK, I will break it for a little while by copying whichever one had the most code, I think. I listed the diffs and kept that in a text file somewhere, and thought, OK, I'll copy everything that's not different into a base class, and then have abstract methods for everything that was different. And in some of those abstract methods, it would be not doing anything for some versions. What I found weirdest was how to model the menu parts up here, or not menus, but you know what I mean, the controller aspects. Because we don't have copy kit to device, we have copy data to device, and we don't have this kit to copy to at all in the module view. So what I've currently got, because I wanted to still have all of this in YAML if I possibly could, data explorer.xaml, sorry, XAML rather than YAML. Don't like YAML, do like XAML. The XAML has everything, and then I just disable a bunch of stuff in the constructor for Kit Explorer and Module Explorer. I honestly don't know whether this is the right approach to UI design. The chances of me hitting on the right approach to UI design entirely by chance are pretty slim, because I'm such a sucky UI designer. But it was really interesting to do, and it took 2 or 3 hours maybe, and there have been a few changes along the way. But so far, I'm quite pleased with the result. Right, I'm running out of time, as I thought I probably would. How many of you were in Troy's talk with Scott Helm yesterday? Yeah. So they were up here, well, on the other stage, saying, yeah, there's no reason why anyone should buy an EV certificate these days. I was thinking, I bought one earlier on. I bought one less than 6 months ago, and from that company that you were saying was rubbish. Oh, no. So I was almost disappointed when I asked the question later on about, does it still make sense to buy certificates for code signing? I really thought that they would take the opportunity to make fun of me for a while. Certainly, if I'd been them, I would have done. But it turns out that when you build an installer, and I knew nothing about installers, I knew there was this thing called Wix, and that I probably wanted to build an MSI, had never done it before. So I spent probably an hour watching a video by a guy called Angel6, who went through how to build a Wix installer, and where there were a few green squiggles for his demo code, I thought, I can hopefully get rid of those warnings, and I did. Probably not in a good way, but I built an MSI. And as of Oren's talk from Wednesday, one of the things, when I get some time, which is in short supply, I will be building an MSIX instead, which I hope will be simpler. Because currently, the reason for having an MSI is you can download this code now and install it with an installer, and it will work, I believe. You probably don't want to. If you've got one of these, I would love to hear from you, and let's actually get some testing going. But I built an MSI, and then I tried to install it, and it said, no, you're not allowed to install it. Or there's a tiny button that says, if you hate yourself, click here. Right? Do you really hate yourself because this could nuke your machine? Yes, OK, install. Like, OK. So Windows Smart Screen, kind of hostile. Right, I need to get a certificate. I will find out how to get a certificate. And a few hours later, I'd applied for a certificate, and then they sent me an email saying, right, you need to get a notary to say that you are who you say you are. It's like, OK, I hadn't really anticipated this. I've already paid a couple of £100 for a certificate, and I haven't even got it yet. So I looked for local notaries. And all of this, I'm not saying because it's important, just this was a learning experience, and also an expensive experience. See back to my point about privilege earlier on. Not everyone can afford to buy a certificate and get themselves notarized just for the sake of a hobby. Count yourself lucky if you can. But now, when you try to install, it says, do you trust Jonathan Skeet? That's your call. I make no judgment. And I gather this is still going to be useful when I convert it into an MSIX. That's still required for Smart Screen to do things. Really running out of time. Point about documentation. None of this would have been possible without the Roland documentation. And I have now written documentation. There's like screenshots and everything. If you browse to the right bit of GitHub, it will point you to a link to the GitHub pages that say, here's how you install it, here are some known issues, et cetera, et cetera. I won't say too much about nullable reference types. They're great. I don't have them turned on in the WPF project yet, or the console project. I definitely want to do it in the console project. Nullable reference types are interesting when it comes to deserializing JSON stuff, because I want to deserialize to this class. It starts off with nothing being non-null. So everything's got to say, I might have a string for you, I might not. And this is a really good reason to decouple the model that you deserialize from JSON from your actual, in my case, schema model classes, as well as you can just design it slightly differently. So things that are nice to represent in JSON and things that are nice to work with in code may not be the same thing. Have that separation to start with. You can validate that you've got all the data you expect to have from the JSON, and then populate the non-null stuff. So coming to reflections on the experience, this has just been so much fun. I hope if you won't take away technical knowledge from this, but I hope you will take away that I have enjoyed myself doing it, and probably you can find something else that you can enjoy doing too. And I have definitely picked up skills I may never need to build an installer for work. But now if I do, I have a bit more experience. If I need to build another installer for some other kit, I now have a certificate, so I can prove I am who I say I am. I've learned things about immutability. I'm starting to learn things about WPF and view models. I'm definitely learning things about system.command line, which it feels like it could do with a lot more documentation, but is probably going to be the way that command lines in .NET are working in the future. This has been such a rich experience. And I'm learning to drum as well, just about, and it's lots of fun. I hope this has been one of the most random talks I've given, and I'm lining up to give this talk several more times, particularly when I'm doing this remotely so that I can have the kit there. So thank you very much for your time. It's now 2 minutes past 10, so if you want to go and get a coffee or whatever before the next talk, you absolutely can. I have a 3-minute video just to show you something that my son Robin requested that I did. If you want to watch it on YouTube later on yourself, you can, of course.
I already had source code for a game of Tetris that I wrote a while ago, so this is just a slight modification to make it controlled by drums. It won't be terribly interesting to watch, but in the bottom right-hand corner of the screen, you'll see what I'm seeing on my little monitor over here, and hopefully you'll be able to hear as well. This is not intended to be good drum music by any means. Anyway, enjoy.
It took me about 3 hours to redo the code that I already have into .NET Core WPF as opposed to WPF from 3 years ago. It took me about half an hour to actually sync up the drum part. But yeah, this is what happens when you have kids who challenge you to do silly things while in a restaurant. Anyway, it is quite a tedious video after, but thank you very much.